Hello, mathematicians, puzzlers, and other curious people. In this problem, we're taking a look at a frequency table, and we're going to fill it in based on this data set. Now, I don't know what this data set is from. It might just be random numbers. It might be from something. I really don't know. Okay, so we've got a column with our bins already set up, so we don't have to choose the bin boundaries. We've got a column for tally marks. Then we'll use that to find the frequency of each bin and then the relative frequency. So let's tally this up first. We've got a 5, that's in the 5 to 9s, a 10, that's in the 10 to 14s, and so on. 7 in this one, 19 in this one, 25, 12, 15, 7, 6, 8, 17, 17 again, 22, 21, 7, another 7, 24, 5, 6, and 5. So I see we've got 10 in the 5 to 9 bin, 2 in the 10 to 14 bin, 4 in the 15 to 19 bin, 3 in the 20 to 24 bin, and 1 in the 25 to 29 bin. Now, relative frequency is always going to be found using the formula F over N, where F is from the frequency column and N is the total sample size. So there are 2 ways we can find that out, and it's a good idea to do both because that helps check your work. So one way is to take the sum of the frequencies. So let's see, we've got 10 and 2 makes 12. Let's see, 12 and 4 makes 16. 16 and 3 is 19. 19 and 1 is 20. Another way we could have done that is we could have said, okay, 1, 2, 3, 4 together is 10. 10 and 10 makes 20. Either way, you could also grab a calculator instead of doing mental math. Now, the other way we can find out the total sample size is to just simply count it up. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 again. So that's 20. Okay, so I see we've got 20 things in this data set. So that relative frequency would be 10 out of 20 for the first, 2 out of 20 for the second, 4 out of 20 for the third, 3 out of 20 for the fourth, and 1 out of 20 for the fifth. We often give these as decimals or percents. So I'm going to grab a calculator for that, although some of these you can do mentally. So let's see, 10 out of 20 would be 10 divided by 20. So that's the same as 0.5, which would be, if we move that decimal point 2 places, another way to do that is hit times 100 on your calculator, would be 50%. So when we say relative, that's always going to be comparing with something, in this case the part out of the whole. So that's why we end up with a percent as a usual thing that happens when we're talking about relative frequency or relative change or any other relative thing we're talking about. But relative frequency is going to be a part out of whole type relationship, where the whole is the entire data set and the part is the current bin. So then 2 divided by 20. I messed up putting that in my calculator because it's giving me 40 and it should be a decimal. Let's see. 2 divided by 20, there we go, is 0.1, which is 10%. 4 out of 20 is 0.2, which is 20%. 3 out of 20 would be 0.15, which would be 15%. And then 1 out of 20 is 0.05, which would be 5%. A good way to check this is to add these all up. So let's see, 50 and 10 and 20 and 15 and 5 make 100, and we're in percents, or you can add the decimals up. So 0.5 and 0.1 and 0.2 and 0.15 and 0.05 give us a sum of 1.0. So we've got the same value either way, just depending on if we write it as a decimal or a percent. Now, as a bonus, I want to show you how we could expand this frequency table to include 2 more columns: cumulative frequency and relative cumulative frequency. So the cumulative frequency in the first line is the same as the frequency. But in the second line, it accumulates with whatever was there before. So we take the 10 we already had and add on the new 2. So that gives us a 12. And these lines are a little different size, aren't they? That makes it tricky to write, but it's okay. We can do it. And then we add on the 4 together with the 12 we already had, and we get 16. We add on the 3 to the 16 there already was and get 19. Add on the 1 to the 19 there already was, and we get 20. It is not a coincidence, it is an expected thing that you should get your sample size as your last cumulative frequency. Then relative cumulative frequency is just the current cumulative frequency divided by the sample size. So in that first line, it's going to be exactly the same. I'll just write the percent this time, 50%. In the next one, it's going to be a little bit different. So we'll have 12 out of 20, which is 0.6, which is 60%. Now, another way you can get this, since we've already got a relative frequency column, is we can say 50% and 10% is 60%. And I'm going to continue that way for the rest of it, just because I'm lazy like a mathematician and we've already got those percents. So let's see, 60% adding on 20%, 60 and 20 would be 80. 80 and 15 would be 95. So 80% and 15% is 95%. 95% and another 5% is 100%. This is also not a coincidence. Your last one should always come up to 100%, because in both cases, your last line is the total of everything. If you're getting like 99%, then maybe it's just a rounding error. And so it would be a good idea to make sure that you're using your whole cumulative frequencies instead of just adding up the relative frequencies. If you get something weird like 73% for that last line there, it probably means you left something out.